My name is Nicholas Masilko, and this is my DSARI submission. I live in a house with 5 other people in South St. Paul, which was built in the early 1900s. It's around 2,700 square feet, but only around 1,800 of that is finished. Similarly sized houses with 6 people use around 2,057 kilowatt hours of electricity monthly. Over a period of 29 days, we used 1,306 kilowatt hours of electricity, with the biggest users being consumer electronics and lighting at 24% and 56%. This chart shows the expected usage for each of the devices I will be measuring, and my sources are either listed in the references or were printed on the box, which goes for the light and the aquarium fan. We are expecting the majority of the power to come from the heater, aquarium, and washing machine. Here we have the timeline for each of the 8 devices. For our constant power devices, we have a clip-on fan, a fluorescent desk lamp, and a space heater. For our variable power devices, we have a fan for a 65-gallon saltwater aquarium, the rest of the aquarium, which means the heater, pumps, and lights, and a mini fridge in the back of the house. For the light, we are just using the light in my room with only one bulb. I noted the number of times the washing machine was used, and am using it as the cycle power device. As you can see in the top right, I recorded all of this data on the Notes app on my phone. I simply asked my family to notify me whenever they turned one of these devices on or off. I converted all the times into fractions of hours to make the calculations later on more convenient. I asked my family to tell me whenever they turned one of the devices on or off. That goes with my light and the constant power devices. The variable power devices are all on 24/7, so they aren't applicable, and I simply recorded how many times every day the washing machine was used. Clicking through these next couple of slides, we have pictures of me recording the power used by each of the devices. When I started recording, I didn't see the requirement to have my face or ID in the picture, so most of these have a second picture proving they are actually my devices. Here's where I recorded the data for all 8 devices. For simplicity, I rounded all the values down to the nearest hundredth. The next steps depend on the type of device. For constant power devices, the daily use E is simply E equals watts when on times average hours on per day plus watts when off times 24 minus the average hours on per day. That right there is a typo. For example, the bedroom fan draws 12.4 watts when on and 0 watts when off, and is on an average of 8.5 hours per day. 12.4 times 8.5 plus 0 times 24 minus 8.5 equals 105.4 watt hours, or around 0.11 kilowatt hours. For variable power devices, the average wattage W is simply W equals kilowatt hours reading times 1,000 over hours measured. For example, my aquarium read 1.52 kilowatt hours after a full 24 hours plugged in. 1.52 times 1,000 over 24 equals 63.33 watts. That answer times 24 gives us 1,520 watt hours every day, or simply 1.52 kilowatt hours. For cycle power devices, the daily use E is simply E equals kilowatt hours per cycle times average daily cycles. For example, my washing machine gave me 0.404 kilowatt hours per cycle, and since it's run 27 times a week, we just end up with 0.04 kilowatt hours again. It's not relevant to the calculation right now, but I did come up with a phantom power draw of 3 watts for the washing machine. Converting to kilowatt hours is as simple as dividing the value by 1,000. Here is the table from 2 slides ago, extended to do the previously mentioned calculations. We go a few steps forward and determine the kilowatt hours per month, which is simple as just multiplying this by the kilowatt hours per day by 30. We also have the total in the bottom right here for each of the usages. The biggest surprises here were the mini fridge, washing machine, and the heater, which we will get to later. According to the figure of 1,306 kilowatt hours being used monthly, our current electricity use only represents 9.5% of our total. As you might recall, the vast majority of our electricity usage comes from lighting and consumer electronics. Part of the reason I didn't measure consumer electronics was because of how bulky the kilowatt meter was, which makes it very difficult to plug into an uninterruptible power supply. We only measured a single light bulb, so this audit didn't encompass a large part of the lighting usage either. Here we have the expected wattage from the start of the video compared to the actual recorded wattage. I included the percentage by which every result varied from the expected wattage, which was calculated by V equals actual use minus projected use over the projected use minus 100. The first part there is absolute value of actual use minus projected use. The biggest variance comes from the washing machine, which is probably because of the cycles I measured were small loads, so I may have mistakenly misrepresented the wattage of an average load of laundry. The next biggest variance is the heater at 60%. While 1,500 watts is a good estimate, A result around 600 watts isn't unheard of, especially if it runs on a low power setting, which ours did. The mini fridge had a significant variance, which is largely due to my error. When I recorded the fridge's energy use, it was only around 26 Fahrenheit outside, and the fridge is it's in one of the least insulated parts of the house. As a result of this project, I have a few insights into how to reduce my energy use. By cutting out usage of the space heater, I can reduce our electricity consumption by 4.55 kilowatt hours, or 3.7% of our total use, though it won't be getting used anyway during the warmer months. By making sure to unplug the space heater in warm months and the washing machine between cycles, I recorded 3 watts of phantom draw, I could effectively save around 26 kilowatt hours per year, though that would only be around 0.2% of our yearly use. If I reorganized and made enough space in the old fridge upstairs, I could cut out use of the mini fridge for the majority of the year, which would save 8.39 kilowatt hours every month, or around 0.6% of our monthly usage. These are my sources, which I will also be listing in the description. Thank you for watching.